This is optimization worksheet number 2. Let's look at number 1 here. It says points A and B are opposite each other on shores of a straight river 3 kilometers wide. So here's the river running through, and then opposite shores, there's points A and points B, okay, directly across from each other. Point C is on the same shore as B, so here's point C, but 5 kilometers down the river from point B. So the distance between B and C is 5 kilometers. A telephone company wishes to lay cable from point A to point C. If the cost per kilometer of the cable is 25% more underwater than it is on land, what line of cable will be least expensive for the company? So we're trying to optimize the cost of laying down cable between points A and C. So the two extremes are having line of cables just go directly from point A to point C. So the advantage, if it's directly from point A to point C, the advantage is that we know that the shortest distance between 2 points is a straight line. So we have the shortest distance. However, this is probably not going to be optimal cost because if we put everything underwater, then it's going to cost 25% more than if it's on land. Okay, so that's one extreme. The other extreme is what if we just found the shortest distance on water, or where the cable is underwater? So that's going to be a straight line between point A and point B. So this will be the shortest distance underwater, which will be the least cost underwater. However, that would mean that you'll have to lay cable along from point B to point C, which is not necessarily the issue because it's on land, so that's going to be cost efficient. However, from point A to point B to point C, that's going to be the longest possible distance. It'll be much longer than between point A and point C. So it's more cost effective in the sense that there's more parts of it on land, but it is traveling a longer distance. So we know that, therefore, the most efficient, cost effective, will be from point A to some point between B and C, and then the rest of it on land. So we're trying to find that halfway point where the cost is going to be minimized. All right, so let's think about the cost equation. So cost equation, we know we're going to find this distance from this point to some point between B and C, and then from this point to point C. Okay, so first off, this distance here is going to be 5 miles minus x, because we know, let's first start off by assigning this distance as x. We know this is 3 kilometers. And so if this distance from point B to whatever this this point is that we want to identify to connect between the endpoints of the underground of the underwater cable, if this distance is point x, is distance x, then we know the remaining portion must be 5 minus x, right? Because we know the entire distance between B and C is 5 miles. So 5 miles minus x will give us 5 minus x. And then this distance here, we can think of this as the hypotenuse of a right triangle using legs of x and 3 kilometers. So Pythagorean theorem, we know the hypotenuse is going to be the square root of leg squared plus the other leg squared. Okay, so root x squared plus 3 squared must be the distance from point A to whatever this new point is. We can call this point D. So we know the cost on land is going to be 5 minus x times 1. Okay, because we're doing relative cost here. If we just assign this land to be $1 per mile, let's use that for convenience sake, then underwater must be 25% more, so 1.25% more. So 1.25 more would be the cost of this distance, which is square root of x squared plus 9. Now we have the cost equation. with optimization problems, once we have our equation, then we just find the derivative, set that derivative equal to 0, and then solve for x. So if we find the derivative here, first off, if we distribute this through here, we get 5 minus x, so the derivative of 5 minus x is going to be negative 1. Okay, the derivative of negative x is simply negative 1. And here, we can go through power rule. The 1.25 is a coefficient. It'll stay in place here. We just take the derivative using chain rule for x squared plus 9 to the 1/2. So we bring down the 1/2. Keep the parentheses. Subtract 1 from the exponent. So 1/2 minus 1 is negative 1/2. Multiply by the inside function's derivative. So x squared becomes 2x. 9 goes to 0. So now we have our derivative equation. We set it equal to 0. And then we can also try and clean this up as much as possible here. The 1.25 goes up top. The 2 cancel, 2 and 1/2 cancels out. X goes up top. Square root of x squared plus 9 goes in the denominator. Now we just set the derivative equal to 0 and then rearrange the equation here to begin to solve for x. Bring the negative 1 over to the right, to the left side. Cross product. Square root of x squared plus 9 is equal to 1.25x. If I square both sides, I get x squared plus 9 is equal to 1.5625x squared. Combine like terms, get the x squared to the left, move the 9 over to the right side. The negatives cancel out, divide both sides by 0.5625. And then we take the square root, we get x equals plus or minus 4. And then negative 4 is not going to make sense since x can't be a negative distance. So the optimal point would be 4 miles down the shore from point B. So 4 miles away, this point will be the optimal point for the most cost-effective solution. All right, number 2 is similar here. It says you are standing at the edge of a slow-moving river at point A, okay, which is 1 mile wide, and you wish to return to your campground on the opposite side of the river. You can swim 2 miles per hour and walk 3 miles per hour. You must first swim across the river at any point on the opposite bank. From there, you walk to the campground, which is 1 mile from the point directly across the river from where you start your swim. What route will take the least amount of time? So again, we're trying to identify this path from point A to here. I got to call this point B, and then from point B to point C. The difference is that we're trying to find optimal time. So let's think about what time is. Time is distance divided by velocity. So if I call this distance x, then I know that this entire distance is going to be 1 minus x. Okay. And once we have that, then we can, we also know that this distance, the width of the river is 1. So then to find hypotenuse, we can do square root of x squared plus 1 squared. Okay. All right, so this is the distance we want to travel, right? But time is distance divided by velocity. So the swim, we can make the swim 2 miles per hour. So we can say the distance for this portion is square root of 1 plus x squared divided by the velocity. So now this represents time that it takes to get from point A to point B. And then from point B to point C, it'd be, the distance will be 1 minus x. And then we divide it by 3 since the velocity for this leg of the trip is going to be 3 miles per hour. So now once we have our time equation split up into 2 parts, we can now find the derivative set equal to 0. So I can pull the 1/2 out in front. The square root is rational exponents to the 1/2. I can split this up into individual fractions. So now I can just go through power rule and chain rule. So bring down the 1/2, keep the parentheses, subtract 1 from the exponent. 1/2 minus 1 is negative 1/2. Multiply by the inside function's derivative. So all this portion is chain rule for this first part. The 1/3 derivative is going to be 0, so that goes away. And negative 1/3 x becomes negative 1/3. All right, so now we have the derivative. We set equal to 0. We clean this expression up as much as we can. And then I'm going to bring the 1/3 over to the left side if I do cross product. Okay, so once I have the cross product here, 3x equals square root of 1 plus x squared. I square both sides. and let's see, 2 squared. Right, so if I square both sides here, sorry, there should be a 2 out in front of here, so it should be 2 square root of 1 plus x squared. All right, one side cross product. Square both sides, so 3x squared becomes 9x squared. I square this expression here. The 2 squared becomes 4. The square root squared means the square root goes away. Distribute through, combine like terms. I get 5x squared is equal to 4. So x squared equals 4/5. Take the square root of both sides. So x equals plus or minus 2 over root 5. But we can't have negative x distance, so we keep the positive. So x equals 2 over root 5.